Hi, this is Zimeng, a graduate candidate from ADS program, iSchool. Today, I'm going to introduce my graduate career. My presentation has mainly four contents: overview, learning objectives, conclusion, and my reference. Let's start with the overview. The application of data science is potentially as diverse as enterprise operations and processes can be, multiplied by a variety of potential data-based decision-making that might affect this operation and processes. To achieve knowledge, how to develop our own cognitive strategy for data-based decision-making, I chose to enroll in iSchool as an applied data science student at 2020 spring. I graduated with a bachelor degree in information and computation science, cultivated a solid fundamental knowledge of mathematics and computer science, at the same time actively seeking for methods that transform basic knowledge into technology and application in real life. So, developing analytical, data-driven report output skills and technology are my ultimate goals of learning, which is also playing a guiding role in my graduate path. There are mainly three goals through my graduate study: data storing, flowing techniques, through courses like ST659 and so on. I learned relational database design and implementation, data warehouse basics like ETL, higher-level data storage and manipulation like distributed store system like Spark. Number two, the database decision model concept and implementation courses like ST687 and so on. For these courses contain various types of analytical techniques like machine learning, statistics model, and implementation in different programming language such as R and Python. So let's dive into my learning objectives. The following paragraphs will introduce detailed coursework and my learning objectives corresponding with outcomes. In the past 2 years, I have done multiple projects, which is also an efficient way to test mastery of my knowledge. Through insinuating past projects, analytical skills achieved are demonstrating. Following paragraph will include learning objectives in detail and how I achieved them. The first is collect, store, and access data. As an entry to data storing techniques, ST659 introduces concepts of relational database, rules of designing a relational database, and the implementation in the SQL Server. For this course project, I cooperated with my partner designing a database for NCAA potential college athletics, design the relational database model, and draw entity relationship diagram in Microsoft Visio. Then, a database in SQL Server is carried out, which is able to solve relating business questions via SQL. At the very last, we implemented a user interface using Microsoft Access before better interaction with database. After access to using basic relational database, data warehouse updated my data flow techniques. ST722 introduced concepts, components in data warehouse, basic model like bus model, and data ETL process through SQL Server integration services. For this course, my group completed the entire process of creating a simple data warehouse, designed the detailed models to combine two databases from two different companies, implementing staging database and data warehouse in SQL Server, extract data from original source, transform and load data recordings into data warehouse via SSIS. And I also learned advanced ideas in data storing method, which is distributed system for Incore's ST718. Usage of Spark expand storage space and speed up calculation. Basic concepts MapReduce and RDD data frame are introduced. Through the in-class project and the coursework, I stored the whole dataset in Spark data frame. Furthermore, conducted lots of data manipulation operations, such as group by table join. And my second goal is create actionable insight across a range of contexts. And in this part, I'm showing that I'm able to utilize data and full data science lifecycle to establish perspectives across a range of contexts. The same course, IST687, was the first course I took, which introduced data science lifecycle. Through the project Southeast Airlines Survey, I built up the whole analytical cycle, including data sampling, data exploratory analysis, data pre-processing, constructing predictive models, model evaluation, and finally making suggestions. In this project, Southeast Airlines company needed to lower their customer churn, like many airlines. Southeast believed that the best way to minimize customer churn was to have a robust loyalty program for frequent flyers. However, their customers were valuing the loyalty program less, which was one reason why just relying on their loyalty program might not be sufficient in keeping lowering customer churn. Additionally, customer churn is actually a lagging indicator, meaning the loss has already occurred. What the company really needed is to prevent the customer from leaving, or they just need a leading indicator. In other words, these leading indicators or metrics could help identify when a customer was about to stop flying Southeast. These insights could provide actionable suggestions as to how to avoid having the customer leave and go to another airline. To achieve the insights, I created predictive models such as association rules, linear regression. Then I can extract meaningful features from models, which is also critical attributes the model was looking at when making a decision. For example, rules with the highest lift in ARA reflected solution to improve customer satisfaction. Attributes in the rules were leading indicator we have to focus on, and Southeast Airlines should improve services as the rules described. Or in another class in ST736 text mining, I was demanded to analyze text, a higher level of information structure. In text, words are basic unit that provide us insightful perspectives. So I was extracting words as meaningful features that has a great impact on prediction. In my project Data-to-Text Mining, people wanted to see whether their communication can affect the outcome of their game and how the outcome is affected. To extracting the word as leading indicator, I built up predictive models like supporting vector machine and a U-Bayes classifier to learn from matched data. In the learning process, vectorization transformed text data into numeric when learning an important feature of the model. I decoded the results into the form of word, and the log probability in NB and weighting SVM ranked the feature importance. Based on this insight, the model was able to suggest that in a game, players should communicate politely to improve the chance of winning. And my third learning objective is apply visualization and predictive models to help generate actionable insight. So in graduate studies, ST707 and ST718 played a critical role to deepen my understanding of predictive models and visualization. Various charts and models like machine learning, deep learning also broaden range of data visualization, predictive model skills. As a result, lots of valuable insights were generated when applying visualization or model technologies. I shared project FIFA 2020 player analysis for both ST707 and 718. I'm going to introduce the project first. I present most of the transfer fees of stars are based on the popularity of the players, which is partially reasonable. In order to provide a more effective method to evaluate a player, I analyzed FIFA 20 player data for a more precise suggestions. For the project, I was trying to provide a reference for player position and salary evaluation based on simulated player scores in the video. The results are capable to benefit the real-world soccer club to decide, like finding the best cost performance player. This project has 3 goals. The first goal is to improve the player's